My name is Minoru Noda from Kyoto Institute of Technology from Japan. So today I'd like to present on this title. This is outline. So firstly, I'll present this first part, a liposome as sensing molecule, the research background, and research object. So, liposome is a closed supramolecule formed by self-assembly by a phospholipid bilayer. This is the shape of the liposome, and its size is about 50 to 200 nanometer in this research. The fluidity of phospholipid bilayer in liposome is very high. So this is a strong origin for with external biomolecules. We use DPPC liposome. So DPPC is 1,2-dipamintyl SN glycerol 3 phosphocholine. Background: when immobilizing liposome on a solid surface, closed spherical shape tends to degrade with short time to bilayered planar membrane. So when we apply to the practical sensor devices, it is necessary to immobilize liposome intact on solid surface for a long time. Research object. It is reported the adsorption becomes different depending on hydrophilicity of the substrate surface. Several papers say the hydrophilicity of the surface, the higher the hydrophilicity of the surface, the more closed spherical shape maintained. But it is still unclear in the present stage. So this time, we increase surface hydrophilicity. So when choosing process for that process, the applicability to the practical sense device is very important. So we immobilized on platinum and gold surfaces because this is very typical. And finally, the improvement in retention time of intact liposome on platinum substrate is our object. So next we move on to experimental. The first part is evaluation of substrate surface. Experimental. To increase hydrophilicity of platinum or gold surfaces, we choose the process. One is some oxidation and some treatment. So they are known to be very effective and applicable to the silicon-based biosensor process. We evaluate the substrate surface first, XPS for oxidation degree, second, contact angle for hydrophilicity. Next, in order to observe time course of variation of liposome, third, FM for surface height and roughness, and finally, XRD for crystalline phase. In XPS measurement, we obtain the surface oxidation degree of platinum surface. This shows the abundance ratio in the substrate. As the oxidation become larger, the abundance ratio, the red is platinum oxidized state, and red and blue is metallic state. The red one increases. Platinum oxide state and its metallic states are compared, and the ratio of oxidized platinum state is observed to increase by the oxidation process. This is a contact angle. Contact angle is measured between droplets of the same volume and platinum substrates with different surfaces. The smaller the angle, the higher the hydrophilicity. And this is a droplet view on non-treated platinum substrate. This left figure shows a contact angle for various treatment, surface treatment. So, in this direction, hydrophilicity increases. So the previous slide showed oxidation degree of the surface become larger this direction. So we find the tendency agree with between the oxidation degree and hydrophilicity. Of course, also SEM some improves surface hydrophilicity too. Next, we move on to time course of liposome molecules. As illustrated here, it is thought from simple estimation, intact shape of liposome deteriorates with time after its mobilization on solid surfaces. That is, surface height and roughness decreases. Therefore, closed spherical shape becomes disrupted. In this experiment, next experiment, time course of surface height and roughness of liposome observed by FM after immobilization by cast method on different surface treatment substrates. This photo is an example of FM image on distribution of DPPC liposome immobilized on a non-treated platinum surface after 3 hours from immobilization. This is a time course of FM images for 30 minutes, 1.5 hours, 1.5, 3, 4, and 24 hours respectively. So the left figure, in the left figure, surface roughness from the FM image are plotted against time. So you can find the roughness gradually decreases. This is on non-treated platinum. We now define intactness here as the ratio of roughness after T hours to roughness after initial 30 minutes. This right figure shows the intactness against time for several various surface treatment. So the worst case is with non-treated platinum. In the top three, best three sample is with thermal oxidations and SEM SAM. So we can say the retention time of intactness was increased by thermal oxidations and some treatments, both. Next is the crystallinity of liposome membrane. This shows illustrates a phase transition of phospholipid molecule of liposome. As the phase changes to this direction to fluid side, the fluidity becomes large. The membrane fluidity will be lost when the phase is not dominated by fluid or gel phases. In this experiment, time course of crystallinity of liposome are measured by XRD after immobilizing on substrate with different surface treatments. This is XRD patterns. The left is red is liposome on DPPC, liposome on platinum thermal oxidized at 750 degrees C. And blue is liposome on platinum non-treated. And green is reference platinum substrate itself, non-treated. So, and with this is as a parameter of time. So in the red, you can find blue. With non-treated, you can find after 3 hours you can find a subgel peak here. So this indicates the liposome degraded from about 3 hours. Compared to this, with oxidized one, after 3 hours there's no peak. In the right hand, subgel peak to gel peak intensities are plotted against time for various surface treatments. This is nearly the same. So after in the thermal oxidation process, this orange and red, subgel peak almost a little observed here. So we can say little subgel peaks appeared on thermal oxidized platinum surface after 3 to 4 hours, and the previous slide, the case and the story on the hydrophilicity, we can say the separation in subgel peak intensity relates to hydrophilicity of surface in every substrate. So we'd like to go summaries. This is summary. Hydrophilicity of platinum surface is increased by thermal oxidation or some treatments. Intact immobilization of liposome is improved by increasing hydrophilicity. Thermal oxidation is the most effective for improving the intact immobilization of liposome on platinum surface in the present experiments. It is noted that the intact immobilization maintains on thermal oxidized platinum surface for more than 3 to 4 hours. And from FM results, also is expected the retention time more than 24 hours, 1 day. So thank you for your kind attention.
Thank you very much for the presentation. We have time for